Hey guys, Lazy Developers here. My name is Melody Leonard, and in this tutorial, we'll be talking about the blockchain. We're looking at basically what the blockchain means and all that. So, the blockchain is a safe way of record keeping, and what it does is it allows you to save data and in such a way that that data cannot just change. It makes it impossible to change. And this is possible because lots of computers around the world verify that when a record is saved there and its contents are, let's say, content A, it actually content A, right? So a hacker cannot just go there and change the content to content B, right? Because they have to get all these computers in the world to verify that this content is now content B. And that is why sometimes most of you must have heard the time that when, uh, when you save something in the blockchain, it doesn't change, right? And before we go in depth looking at all that, let's write our first code and deploy it to the blockchain, right? This is actually going to be a local blockchain, but it actually wows you and actually, you know, gives you this context of what we are actually going to venture. And in the next tutorial series, we're actually going to go ahead and explain what the blockchain is. We're going to explain some terms like the gas fee and all of that, right? So what you see here is actually called Remis. Remis is an online IDE. And what it does is it allows you to just hop on, write a code, and you don't have to bother about setting up things locally, setting up Ganache, having some uh, account or fake account or and stuff like that. You just go ahead and write your code, and it actually compiles it and deploys it to the Ethereum blockchain, a local Ethereum blockchain. But yeah, it does the job, right? So what you see here is actually a license, right? It's just a license. I'm just specifying that this is the license we are going to be using. And at a point, right, this was actually added more recently. When I came back to writing smart contracts, I wrote a code and tried to compile it, and I got a compilation error. And it was telling me that I had to provide a license. And so, for some reason, this thing you see here, you have to actually provide it. I don't know if you're using a different compiler or you're actually somewhere else in the world. This might be different, right? Let's pray it's different, but yeah, you just have to do this. So for Ethereum, right? Like Ethereum, the blockchain technology is more of, or let's say the smart contracts here in this context, which is written. You have to write a smart contract and you deploy it to the Ethereum blockchain. So Ethereum has its own blockchain that allows you to deploy these things called smart contracts, which are codes, right? So you can have different code. You can have a token there, a sub token under the Ethereum blockchain, and all these crazy things and stuff like that, which we are going to explain later. But we'll just want to go ahead and write our first smart contract. So what you want to do is define your compilation or your compiler, the compiler you're going to use. You want to compile with a certain compiler or stuff, right? So the way you do that is use something called the pragma keyword. So you're going to say pragma, and you say solidity, what solidity compiler you want to use. And I want to actually use something greater or equals to the 0.7.0 and something less than 0.9.0. And this does it. So Ethereum, unlike many languages, Ethereum actually ends each line of code with, Solidity actually ends this line of code with a semicolon. So, unlike many other languages, JavaScript allows you to ignore this, right? You don't have to do that. You don't have to do that in Python. Some languages you have to definitely do that to have your code running and stuff like that. But yeah, here we go. So, what we are going to do is basically have a number saved in a blockchain, and we are just going to retrieve that number. Yeah, I know it sounds very simple, but well, when you go deeper, when you get well maybe deeper, you actually get the importance of this. This actually part of our you know part of our prod operation where you have to save a number and retrieve it, right? Or create a number and retrieve your number, which is the uh, create, which is the post, and get operation, right? So your code of in every file, that's in every file of the solidity, actually lives in this thing called contract. So contract, then you call the name of what your contract is going to be. For this case, we are actually saving a number, so I think we should actually call it number, right? So we're going to go ahead and call contract number and this. Now we can start writing our code. Now, Ethereum is actually, sorry, Solidity. I don't know why I keep saying Ethereum, but yeah, you get me. So Solidity is actually a type language, right? It means that you have to define your types before you use them. In JavaScript, you don't have to do this. Well, TypeScript allows you to do that, but cases like I don't think you have to do that in Python, right? But yeah, with Solidity, you have to define your types before you use them. And we have lots of types, guys. Like there's different types in uh, Solidity. You can actually do that by going to Solidity docs.soliditylang.org, or you can just go to the Google and type Solidity, and probably the first thing you see, go there. Let's look for types. Just go to uh, and here is a compiler we spoke about. So you look at the types. When you click these types, it's going to take you to this place. You see that we have a boolean, which is denoted with bool. We have integer, which is denoted with uint, int, and you know, and all those things. And what uint basically means is unsigned integer. Unsigned integer is actually a positive integer, so it can be negative. You can put -5 and stuff like that. And we have actually something called address, right? Where is it? Where is it? Oh, I can't find this. Okay, here it is. We have address and we have basically others, right? But that is not what we're trying to achieve right now. We just want to write our code and deploy it to the blockchain and see that it runs. So we can be wild, right? So we'll go ahead and say uh, our number is going to be an unsigned integer. So let's initialize our variable number. So we're going to go ahead and say on uint, right? So this is uint. And uint, recently there was an update in the Solidity, so you have to actually specify that it's actually going to be 256 characters, or you can specify less, right? I think there might be lesser. We might have lesser. Let's go to the int and see. So you can see uint, we have 255. We have int 8, right? And that, right? So you can just go ahead, guys, and look at this documentation and see what works and what doesn't work, right? But for the now, we just want to write our code that accepts a number and gives us back that number. So uint, let's call it number, right? So what this means is that we have a number which is actually an integer of not more than 256 characters, right? So yeah, and what we want to do is we want to have a function that actually accepts a number. So we are going to have an input. Let's say in the front end, we are going to have an input where a user can type a number, you know. So this function accepts that number, and what it does is it saves it for us. It actually references to this number here, because this number is just being initialized. It's not being used. It's not being defined. Like there's no number to it. You can't say that this is 8 or 5 or 10, right? So we want to do that dynamically, right? So let's have a function. The way you call a function in Solidity is by using the function keyword. So you say function, you give it your name, function keyword. So you can say save number, right? Function save number. And remember, our function wants to accept a parameter, right? So this parameter is whatever number we are going to pass into it from our input, right? When it accepts this, inside the function, it just saves it. It just references it to this, this number here. So whatever is going to accept, remember, so this is a type language, so you're actually going to need to define that whatever you're going to accept is going to be a number or a string or an address or whatever, right? In our case here, it's actually going to be a number. So it's actually going to be a uint. Let's say units. Uint 255, and we can call it basically anything. right? So we can say it's a number, right? It doesn't matter. You can call it a num. You can even say it's a string here. It doesn't make it a string, right? You can say it's a string here. But you can't use this string because string is actually a keyword. So you can say S or whatever. And if you're actually a programmer, if you've been writing code, you'll know this, right? You can call it anything at this point here. So we don't care what it is, right? You just say, okay, this is like a variable. Here, you can say the variable num is actually what's going to be passed in by the user. And whatever we choose to do with that variable is our issue, right? Like this is a variable too, like this is a variable as well. So we go ahead and say, well, this function, we want to make it visible or public, right? And that way you use the keyword public. If you don't use the keyword public, I don't think you're actually going to have the visibility to yourself, right? You have to explicitly define the visibility of this function. And by using public, you're actually saying that it's public, right? We'll go ahead and open a function or create a function. So in this function, what we just basically want to do is save some data. So we want to save this number. So whatever is passed in from the user end, which is this num here, we want to see that the number we have here, which is actually just initialized, is actually going to be equals the number or whatever the user passes. And that is all, guys. That is all. So right now our function works, right? So we can go ahead and save a number. And let's go ahead and compile it, right? If you go to this place here, if you hover over it, you're going to see the contents are changed, blah, 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 recompilation. This actually compile your code, right? So you can go ahead and compile this. And it compiles with no warning, right? So let's verify that. I just don't know why this is stressing my life. Oh Jesus, this is so. I hate this thing. Like the precision, you have to go very precise. Guys, I'm sorry about that. But yeah, you can see that we actually compile this code, so we can recompile, and you see that there is no warning here or anything. So we can go ahead and go to this place here. If you hover over it, you're going to see it says deploy and run transactions. So we can go there. We can deploy this transaction, right? And you will see, watch here, you see that it actually says successful. This green tick here is actually going to it actually means successful. And you can go ahead and look at all the you know info about this. I hate this. I don't know why I hate this, guys. I just know what I'm gonna leave it. So you can go ahead and scroll and you see true transaction mined and executed success. You'll see the hash, and you can see the user, like the account is coming from here, and this is equals to this here. This is the account here, right? So it gives you, like I said, remix actually gives you a fake account, or just lets you do things without bothering about how you're going to configure things. And so, and you can see the gas fee is actually this, right? And we'll talk about this in a while. You can see the transaction cost, the execution time, and hash, and so on and so forth. So let's go ahead and see our transaction. So this is our transaction here. If you open it, you can see that it actually gives us this free interface where we can do our operation. So it actually gives us Remix actually gives us this free input. So I can go ahead and say 54 and save number, and it saves for us. You can see this here. If you observe this, you can see that actually this was successful. And if you scroll there, you'll see that okay, it's accepted an input, which is a uint number or num, and which is 56, and that is corresponding to this here. So you see, guys, we've been able to save our number, but there's no way currently we can get it apart from this place where we could just see that okay, this works and stuff like that. So let's write a getter function, right? Let's write a function that's called function get number, right? uh, so function get number doesn't accept any inputs, right? Because we don't want to pass anything to it. We just want to get whatever we push to the blockchain and stuff like that. So get number we're going to say that this get number is going to be public and it's going to be view, right? You have to specify this view, which means actually you can view it and or see it and stuff like that. And you want to specify the return type, right? So you have to specify what the return type is going to be. Remember, Solidity is a type language, so you have to specify what you're actually going to get. So you say returns, you know, in this case, we want to return, uh, what are we returning, guys? A uint, uint, uint 256, and this works for us, right? So with this, we have this setup, right? So we can go ahead and return it. And this is not rocket science. What all we just do is we've been able to assign this number to wherever the user puts in, which is here. So we just want to return this, right? And the way you do that is just to write return number. There you go. And you put your comma or semicolon. Sorry, semicolon, right? Oh, guys. So you put your semicolon, and there you go, guys. So you've been able to write a first smart contract that saves a number and retrieves that number. And you're doing a very nice job, guys. So let's compile this and see what happens. No error. That's cool. Let's go ahead. Now you see that if you check this, it doesn't give us a get for our get number. And that is because when we deploy the first instance, right, it just doesn't change. That code has gone to the blockchain. It's going to be saved forever, right? This is local blockchain, right? You can go ahead and delete it. Aramis allows you to do that. But if you're actually deploying to the real blockchain, right, it's actually going to go there and be saved forever. So you want to write tests for your code. That's why you hear that blockchain developers like write tests a lot, right? You could just write a very small file, but you want to test every use case, right? So your code doesn't run unexpectedly. So we are going to go ahead and redeploy this. We can go ahead and remove this right from the list so we can see our different instance. Or you know what? Let's just leave it. Let's go ahead and redeploy this code we've written or this change we've done, and you see that it's successful. So if I go ahead and close this pane here, you will see that we have another instance of our code deployed. So if we open that, you can see that there is save number and there's get number. And remember, Remix just provides you with these things for free. It just provides you with a free get or a button that allows you to do this. If you're integrating with a front-end application like React, or you're doing HTML stuff and stuff like that, JavaScript, you have to actually create your button yourself and all that. So I can go ahead. You see, the first number which we saved, which was 56. If I go ahead and run a get, you're going to see nothing, like it's just a zero, because that instance is just not the same as the code we just deployed. So I can go ahead and add a different number now, 58. And when I say get number, what happens? Oh, sorry, I didn't save the number. So let's save it. We saved it. Good. Get number, and we have 48. And there you go, guys. So let's try and put another number here. Let's say 67. Save the number, and get number is now 67. And with that, we just have written a very powerful smart contract. I'm kidding, guys. This is not powerful. So, but we've been able to understand what happens, right? We've been able to write our first smart contract and deploy it to the blockchain, the Ethereum blockchain, guys. And in the next tutorial series, we're actually going to be looking at what blockchain actually is, how it functions, what's under the hood, right? We're going to look at all these pieces that connect this blockchain, that brings about this term blockchain technology. And we are going to look at other things, like in the next few tutorial series, we're going to be looking at other things, other types, and how to write maybe something a bit more usable than just saving and retrieving numbers in the Ethereum blockchain. Lazy developers here, and it's nice having this section with you guys.